It's now coming to this SAR-SD technology, that is what structured analysis or structured design. What this structured analysis and the structured design is. Actually, before going to this structured analysis and the structured design, these structured analysis and the structured design techniques are being evaluated or being developed by using different methodologies. So these are the following methodologies. So by using these methodologies, having those four methodologies there, so identifying those four methodologies and taking the important concepts and the principles from these four methodologies, this SA and SD software structured analysis and structured design are being implemented. So this SA or SD technique can be used to perform high level design. Now what is this SA or SD methodology is? The main representation of SA or SD methodology is structured analysis and structured design. So what structured analysis is? Structured analysis is dividing or decomposing the function into smaller parts. Here what is structured analysis is? Making a large function into smaller functions. Now what is structured design? So whatever the function we have decomposed, again making those smaller functions into a formalized module or into a formalized structure. A module structure is formalized. That is means nothing but a proper structure having all those small methods, taking all those small methods, considering the small methods, making all those methods into one structure or making all those functions into one module. That is what structured design is. So what structured analysis is? Structured analysis is analyzing the function, analyzing a large function and dividing it into smaller functions. What structured design is? Taking the smaller functions and making them into modules or making them into an appropriate structure. That is what structured design is. Now coming to functional decomposition. What functional decomposition is? So functional decomposition is analyzing a large function or analyzing a function and decomposing that function in a hierarchical manner. So decomposing that function in a hierarchical manner. So while decomposing that function in a hierarchical manner, as how many parts we are decomposed, that means how many smaller functions we have made, all those smaller functions must be in detail and in understandable. That is why this hierarchical decomposition is not only dividing into small programs, can also be called as making as detailed functions. So with this what happens is the high level data is divided into more detailed data. That is what with functional decomposition is. Decomposing a large function into smaller functions such that making it as a detailed function and also dividing high level data into detailed data. Now structured analysis. What we are doing in structured analysis? So as of now, by dividing the large program into smaller functions, making those smaller functions into one particular module, this is all what we are having is, we are having a textual information. That is whatever the project or whatever the problem we are whatever the problem or whatever the technique we are having is, now we transform Now what we are doing is we are transforming this into a graphical model. So whatever the textual information we are having, we are framing that into a graphical model, that is called as data flow diagrams. That is called as data flow diagrams. So why we are using these data flow diagrams is, using this data flow diagrams we can represent the flow of data with the flow of data in detailed, with the detailed functions or with the smaller functions which we have been decomposed, which we have decomposed. So with the DFDs, what can we present is, DFDs are pictorial items, that is a graphical representation in which we can give the structured analysis of the data flow from one function to another function, or we can also identify the decomposition of a larger function into smaller functions with the help of the DFD diagrams, simply called as data flow diagrams. So with this DFD, what we have been representing, whatever the functions that are being represented in the DFD, so identifying the flow of data from one function to another function, identifying the functions that are acting on the same data. So on identifying those, we can make those functions into one module. With the DFDs, we can make a module structure. So DFDs also helps in creating the module structure. Now whatever the module structure we have been creating with the help of the DFDs, that module structure is called software architecture. So now what software architecture is? Software architecture is one which gives the detailed design, a refined detailed design, which can be, that is what is, which directly shows the preliminary part of the developed product. What the software architecture is? Software architecture is nothing but it is considered as the pre-release or the pre-show of our developed product. With this software architecture, we can show the structure of our product, the structure of our project, or the structure of our product, and how that product is being operating. What are the functions that are being operating in that can be clearly represented with the software architecture. సో అందుకని సాఫ్ట్వేర్ ఆర్కిటెక్చర్ ఏమంటున్నాం, ప్రీ రిలీజ్ అంటున్నాం. సో ముందుగానే మనం ఇలా ఉండబోతుంది, మన ప్రాజెక్ట్ ఇలా ఉండబోతుంది, ద ప్రోడక్ట్ విచ్ వీఆర్ బీన్ డెవలపింగ్, ద ప్రోడక్ట్ వుడ్ లుక్ లైక్ దిస్ అని చెప్పి రిప్రజెంట్ చేస్తున్నాం. దట్ ఈస్ వాట్ ద సాఫ్ట్వేర్ ఆర్కిటెక్చర్ ఈజ్. నౌ after giving that software architecture, after representing the flow of operations or whatever the operations or whatever the actions that are being representing with that software architecture, now all those operations are to be transformed into the code. So for that, whatever the operations we are having, based on the operations, based on whatever the logic we need to represent there, based on the operations, we also go with a conventional programming language. With what programming language we can all make those operations run successfully, that also been evaluated or identified in this detailed design. That is, in making of software architecture, we can clearly identify the model of our product, and we can clearly identify the operations and their flow, and then also we can suggest what kind of programming language we can use to make it into a real-time product, that is writing the code in executing all those operations. That is what we can identify with software architecture. Now the differences to structured analysis and structured design. So it is simply, we can represent the difference means there is only one difference we can show, the one primary difference. whereas the structured analysis is representing our textual information, or representing whatever the functions or whatever the operations we are having, whatever the whatever the functional requirements we are having, framing those functional requirements into data flow diagrams is the structured analysis. Flow diagrams, representing the flow diagrams is structured analysis. Now structured design, identifying the functions that are operating, identifying the functions and mapping those functions into a module structure is structured design. That is the difference to structured analysis and structured design. Now, so this is what all the differences to structured analysis and structured design. Now, the structured analysis relies on two basic principles. One is top-down decomposition approach and the other one is divide and conquer principle. What is top-down decomposition approach? Top-down decomposition approach is nothing but dividing a high-level function into smaller functions. That is what top-down decomposition is. Each function is considered individually, that is isolated from other functions. Decomposing a larger function into smaller functions. That is what top-down decomposition approach. Now, after decomposing the higher function into smaller functions, what we are doing next thing? The next thing is we are making all those smaller functions. We are identifying the smaller functions and making those smaller functions into one module structure, into mapping them into one module structure. That is what divide and conquer principle. So with the top-down decomposition, we are dividing a large program into smaller functions. Now, whatever the smaller functions we are obtained, we are identifying the smaller functions and mapping them into one module structure. That is what divide and conquer principle. And the next thing we are doing with the next principle with the structured analysis is representing graphical representation of results using data flow diagrams or using bubble charts. Now, what data flow diagram is? DFD, data flow diagram, is an important technique which is used to represent the structure analysis of the system. The results of the structured analysis, or which is used to represent the structured analysis of the system. So, it shows the flow of documents or items in an organization. So why DFD is very popular? Because it is popular, DFD is popular because it is simple to understand and use. So it is become the popular because it is simple to understand and use. Why it is simple to understand? So it gives the flow of data from beginning to the end. What is the beginning point? From this point, what is the data transferring to where? So that is the second one. Okay, this is the second stage. In this second stage, what happened? So what was the result in the second stage, and this second stage, is there any other things that are needed for second stage to get or to communicate with? All these kind of the things will be designed with data flow diagrams, so that DFDs are very helpful in project environment. Every project will be for every project there will be the DFD design. Without DFD design, the project cannot be completed easily. Now, so it is a hierarchical graphical model where we show the different functions of the system and the data interchange among those functions. That is what DFD is. We will have a graphical representation. With that graphical representation, we will show the functions and the communication among the functions. So every function will have some input data and produces some output data. So what is this function processing is? So this function processing is considered to be as function consuming some input data and producing some output data. So this is what an example of DFD diagram. So now a car is to be developed. A car is to be developed. Okay, fine. Now we have to give the design of that car. ఇలా డెవలప్ అవుతుంది కారు, ఇందులో ఈ ఆపరేషన్స్ ఉంటాయి అని చెప్పి చూపించాలి. సో దట్ ఈస్ వాట్ వీ నీడ్ టు షో ఇట్. వీ హ్యావ్ టు క్రియేట్ ద డిజైన్ ఆఫ్ ఏ కార్ and then we have to present that design, and we have to show these are the operations that are being, these are the functional requirements that are being presented with this design, satisfying the customer and the end user. So for that, see, engine store is one repository, door store. What from the engine store, what we are doing? Engine store is one unit. From the engine store we are taking the engine and fit engine. So what the things that chassis store is doing, what is the things that the wheel store is doing, what is the things that door store is doing. So idantha okate function ga raskunnam anukondi. Now there will be the that it will be difficult to manage or to identify all the operations. So what we are doing, we are dividing it into parts. One is engine store function, one is door store function, one is chassis store function, and the one is wheel store function. So with the engine store function we fit engine. With the door store function we fit the doors. With the chassis store we fit chassis. With the wheels store we fit wheels. Now it is only using these functions we are performing some operations. Now if all these functions are united, then only we can go for making a car. So earlier it is divided, now we need to conquer all these functions and then we can produce the car. That is what we are doing here. Assembled car and then painting, testing for the testing. If it is okay and it is made and the car is delivered. So later when we move deeper into DFD diagrams, there we can explain what is these cross lines, what is those round symbol indicates, what is those two parallel lines indicates. That we will discuss when we move further into data flow diagrams. So this is what our final car comes out. Now what the DFD is? A DFD model uses limited types of symbols. It is having a simple set of rules which is easy to understand, and it is represented as a hierarchical model. Now what hierarchical model? Why the human brain understands hierarchical model rather than DFD. So human mind, whatever the human mind we are considering here, that human mind can easily understand the hierarchical model, because in a hierarchical model we start with one point, we start with a simple abstract model, or we start with the first point of the system, and from that details, from there what we are doing is we are slowly segregating it into detailed functions. So such that what happens is that frames the detailed hierarchy. So that is what if I want to find my relationship with my family members, now with that how I am taking is, so first I will consider my grandfather, and then so how many children are there for my grandfather. Okay, taking the children, whoever, suppose if the grandfather is having 3 or 4 kids, now except my father, the remaining all will be the brothers and sisters. Now what is the relationship to me? Except my father, what is the relationship to me with the remaining people? Now, if my father has a brother, then if the brother has if he has any children, then what is my relationship with the children? That can be clearly understood. That is what it is easy to understand. With the tree, with the hierarchical model, it is easy to understand. If not in a hierarchical model, suppose if someone in our family member says that he belongs to some, he is the son of, and he is the son of, like this, if they have been saying the relationship, we are not able to remember that. But if we have given a pictorial representation with a hierarchical notation, then we are slowly introduced through hierarchies, and then we can easily understand it. This is what hierarchical model is. So a top level model, a top level function which is divided into sub-functions. Again in a sub-function we can divide it into another sub-functions. That is what hierarchical model is. So now these are the different symbols that are used in DFD, that are used in drawing a DFD diagram. Primitive symbols used for constructing DFDs. In order to create a DFD, these are the symbols that we have been using. So what the symbols, what each and every symbol represents, and what each and every symbol denotes, that we will discuss in the next class. Thank you.